Okay, so let's look at this set of the paper, right? October, November 2021, paper 11 and 13. Okay, let's look at the questions here. Okay, the first question that we have here is, okay, it's about the roots of polynomial. And they have already like given us like lots of the infos here. So including all the sum of roots, sum of square, and also sum of cubes of the roots. So they give us this form of the cubic equation. So basically the cubic equation here is they actually left out all the coefficients there. Okay, so we need to find the values of the B, C, and the D here. So what we have for the first part, okay, to find for the B here, so we could actually use the sum of alpha, beta, and so on. So this B here is related to the sum of the alpha. So sum of the alpha here is negative B over A. Okay, so the A here is a 1. So negative B, okay, with the value which is already given for the sum of alpha here, we can easily find the value of the B. Okay, and then, okay, now let's say if we want to find try to find the C here. So before we can actually find the C, right, we know that this C is related to the sum of the alpha beta. So we also have the information which is like the sum of the alpha squared. So we can use that information, okay, by using this identity here. So sum of alpha squared is the sum of alpha whole thing squared minus 2 sum of alpha beta in order for us to find the sum of alpha beta because we have got all the values given there already. Okay, so the sum of alpha is a 2 and we know that this sum of alpha beta here is C over A. So from here, we can also find out what is the value of the C here. Okay, so as for the value of the D, right, we need to do it a bit differently. So D, we know that it's actually a sum of alpha, beta, gamma. Okay, but in this case, it doesn't work because it's very difficult for us to obtain like the sum of alpha, beta, gamma by using that information here. So we have to turn to like use a slightly different way to do that. Okay, which is the fact that we can actually make use of the SNs. Okay, so from the equation that we actually have got earlier, so we can change it to the SNs form. So S3 plus BS2 plus CS1 plus DS0 and so on. And okay, the S3 value is the sum of the cubes that we have here. Okay. And okay, the rest of it, like all the B's, S2 is already given in the question as well. C, we also found it, and S1 is given. And D is what we want to find. And for the S0 here, we know that it is actually a 3 because we have got 3 roots here. Okay, because Sn is like alpha power n, beta power n, gamma power n. So S0 is a 3 here. Okay, and then at last, when we actually try to solve for the D here, the D value is giving us a 1 here in this case, right? So that is how we look at the first question. So second question, using standard results from the MF19 to find this sum in terms of the n, fully factorizing your answer. So this should be something that we should be very familiar already. Okay, it is all about like we expand the expressions here to get all the r cubes, r squared, and so on. And then later on, it is to just apply, okay, those results that we have from the MF19. Okay, and then after that, it's just to try to factorize the common terms out. Okay, so the common terms here that we could see includes like we have got the n plus 1 that we could factorize it out from all the terms here. And it is also good for us to factorize the fractions. Okay, so the fractions here, because we have got like 1 over 4, 1 over 2, and 1. So it is the best for us to factorize out the 1 over 4 such that we want to avoid any fractions here. Okay, by all means, we just want to avoid fractions. So it's easier for us to work on that. Okay, so we just have to tidy up the last term there, expand and tidy up. So we get this expression, n squared plus a 5n plus a 6. And because this could be factorized, okay, so it could be factorized until like we have got the n plus 2 and n plus 3. So this is where we really factorize it, and we will just leave our answer in this form. Okay, because also like the question also say already, so it's fully factorizing your answer. Okay, so you have to really like do that. Okay. For the part B, okay, express this 1 over r plus 1 r plus 2 in partial fractions and use the method of differences to find the sum here. So this would be the partial fractions. Okay, I think I don't need to go too much about it. So now we are trying to sum the whole thing here. It's the same as we are trying to sum that partial fraction that we have. Okay, so we need to list down the terms, okay, until we can see the cancellation pattern. So it's to list down like when r is equals to 1, 2, and so on, okay? And for the last few terms, you also need to list out, okay, clearly as well. So r equals to n, and then n minus 1, and so on, all these. So as we actually try to list out the terms, we will have to see how the terms are cancelled off. So the combination of the terms that cancel off would be like 1 over 6 plus 1 over 6 minus 1 over 3. So you can see it is actually being cancelled in a diagonal way like that. Okay, of course, you need to show a little bit of the working. Maybe you could do that by putting the dotted lines there. Okay, so you can see how the terms cancel out. And after that, you just have to write down all the remaining terms. So this would be the result after we tidy up. Okay, this one is also not to say very complicated as well. Okay, so deduce the value when we have got the n approaches infinity. So for this one, okay, the n approaches infinity, right? It will actually affect the terms that has an n here. So it will affect this one and also this one here. So an n approaches infinity, both of the terms will approach 0 because those are the reciprocal terms. Okay, so both will actually approach 0. So at the end, what we have is just the constant there, the 1 over 4 there. Okay, but again, like this is a deduce question and it has only 1 mark. So usually the working or the explanation here is not important. They just want to see whether we have got this value or not. Okay, it is just like that. Okay, so if you look at the next question. Okay, so this is a induction question. Okay, it looks a bit challenging, okay, in the beginning, but it is actually not very difficult once we actually get the idea of it. Like, why is it they have got like such weird thing here? Okay, so we need to be clear. Yeah, what are we trying to prove? Yeah, we are trying to prove this statement here because it is the statement that follows after the proof by mathematical induction that this thing. Okay, so this thing is not helping us to prove it. It's not what we want to prove, but it is only helping us to prove that. Okay, so everything we just focus on what I have actually circled here. And one thing that we have to be aware is the n is greater or equals to 2. Okay, so is to let the pn, okay, as usual. So what happens is that, okay, we will have to find out the first case, we verify the first case, which is the ln A2. So from the ln A2, okay, we need to verify. The ln A2, we need to verify that it is greater or equals to this. Okay, so we are also given this number here. So if you have got the ln of the A2, it means that we have got the ln of the A1 plus 1 over A1, the whole thing cube. So they also tells us already that A1 is a 1. So we sub that in, so we get like 3 ln 2. So this 3 ln 2 is the same as, okay, what we have when we sub in the n to the right-hand side here. Okay, so it's 3 to the power of the n minus 1 ln 2. So it's the same. So the first case is correct. Okay, so we can say that the P2 is true. Okay, so now it's assume the PK as usual. Right? So when we move to the next one, right? When the n is equals to k plus 1 here, we are proving for the pk plus 1. So what do we want to see? This is an inequality, right? If this is an inequality, the thing that we want to see is that ln of the ak plus 1 is something until the last thing that we want to see is 3 power k ln 2. The 3 power k ln 2 is the last thing that we want to see in the proof here. So in the middle, how do we actually prove? So it's to use this, okay, relationship that is actually given for us to prove that. So we sub that in. Okay, so we use the relationship here, and then we move the 3 down, and then we are looking at this is ln of an ak plus a 1 over ak. So here, you notice that there is actually one clue which is given here. So we are using this clue here. Okay, so ln of the ak plus 1 over ak is greater than ln ak, right? So what is the log AK here? So the log AK here, we can actually again make use of the assumption. Okay, so when we actually have got the assumption here, then we will actually have got like this is the 3 power k minus 1 ln 2. Then after that, we just have to tidy that up. So this is the last thing that we want to see that. Okay, so yeah, after that, it's already proven. So the pk plus 1 is true. Then by using the mathematical induction, we just have to restate what we were trying to prove. Okay, and then this is the result. Okay. So this one is this question is actually quite nice because all the necessary stuff they already like prove like sort of give us a hint there. So it's actually not to consider a very difficult question compared to some of the question which is in early years. Okay. So let's look at the next one. It's a transformation question. So given we have got this matrix M, matrix M represents a sequence of two geometrical transformation. State the type of each transformation and making clear the order in which they are applied. So we know that here we have got two transformations. And if the M is given by like the product of the two matrices, right? So the one that is being done first is the matrix that come after. So this is the first transformation. This is for the second transformation. So for each type of the transformation here, we need to identify. For the first one is a stretch because the tree here. So in this case, it's like from 1, 0, it becomes a 3, 0. And for the 0, 1, it will still stays as the 0, 1. So this is the stretch. Like this. Okay, so it's a stretch. So it's a stretch in the x-axis, or we say parallel to the x-axis, and we need to mention about the scale factor. Okay, and then followed by, so the order is important. So the second one is we write the followed by, and then we are looking at the second matrix here. So when we see like this matrix here, it's through the recognition. So we recognize that this is a matrix that is rotation anti-clockwise. Okay, so we just have to mention the anti-clockwise rotation, the angle we don't know yet is a theta. So we need to always remember we have to mention about the center of this origin here. Okay, so we need to mention about the center is at the origin. Okay, that's for the part A. Part B, find the value of the data for which the transformation represented by M has exactly one invariant line through the origin, giving your answer in terms of the pi. Okay, before we can find the invariant line, we need to expand the M first. Okay, so just expand it, and then this is what we get. So later on, we proceed to find the invariant line. So it's as usual, we use the matrix, multiply by xy, then we get the x prime, y prime. That we are getting two equations from there. And now we relate them. The line is through the origin. So we relate them by using the y prime is equals to mx prime. Sub in y prime is equals to mx prime. Okay, so we multiply the mx prime here already. Okay. And then further on the y, we need to substitute by the mx. Okay, we substitute by the mx here. So then this is what we get. And then we just have to collect all the terms together. Okay, so when we collect all the terms together, this is what we get. Okay, for the quadratic. So the quadratic is actually quadratic in terms of m, right? So just that for our quadratic now, the coefficients are all in the cos and the sine thingy. Okay, so now the question says that it has only one invariant line. One invariant line means there should be only one value of the m that we have from the quadratic here. So if we only one value of the m, it means the quadratic equation here has got equal roots. So for the equal roots here is b squared minus 4ac is equals to 0. So we really sub in those coefficients in terms of like all the data there. So somehow later, we are going to work with like either cos square or sine square by using the identity. So here, let's say I use the cos square to work on that. All right. So with that, we are getting like the cos square is 3 over 4. And the cos theta here is a plus minus 3 over 2. And in which, okay, it is giving us the value of the theta here is pi over 6 and 5 pi over 6. Okay, so that's how we get the value of the theta here. Okay, because they already said the theta is only from 0 to pi. So this is the values that we get for the theta. All right. Okay. Next. This is a vector question. Okay. So for the vector question that we have here is I've got this plane equation. So recently they really like to ask the plane equation, which is like this parametric form. So we need to be able to like know how to find the Cartesian equation. So for Cartesian equation is we need a point and also a normal. So basically this is the point that the plane will pass through. So we don't have to worry about that already. Okay. And to get the normal, we need to have the two vectors here because these two vectors are parallel to the line. Okay, so these two vectors are parallel to the line, so we can cross them to get the normal. Okay, this is the normal. Okay, we get the normal here. So with the normal and the point, so r dot n equals to a dot n. So the point that it passes through is the first term that we see here, -233. Okay, so after that, just tidy up, and this would be the equation of the plane that we want to look for. Okay, so line L, okay, passes through the point P with this position vector, and it is parallel to the vector K. Find the position vector of the point where the L meets the pi. So it has got this point parallel to the K. So the K here is 0, 0, 1. Okay, so don't get like surprised at why suddenly they have got like this vector K here. It's actually just 0, 0, 1. Okay, so we can actually get the equation of the line. So to find the intersection is very straightforward here. So that is to consider like substituting the x, y, and the z coordinate from the line to the equation of the plane here. Okay, so with that we can actually get like the t value such that with the t value, when we substitute that into the equation of the line there, right, it helps us in finding what is the position vector of the intersection. Okay, so this is the position vector of the intersection there. Okay, so until here is all right. So for the last part here, do we have a D? Okay, wait. So for the part C here, find the acute angle, okay, between the L and the pi. So this is the line and the plane, okay, the angle between the line and the plane here. So we have to use dot product as well. So the dot product here will involve like the normal of the plane and the direction of the line now. Okay, so we do the same steps like what we did in the dot product, okay, to find the angle. But here, specifically, if you want to find the angle between a line and a plane, if you want the answer directly, we can replace the cos with the sine there. So once we actually replace that with the sine ready for the formula here, the answer that we are getting here is straight away, okay, the angle, which is like 39.8 degree, okay, for the acute angle here. Okay, whereas for the last part here is to find the perpendicular distance from the point P to sorry, the point P to the pi here. So we have actually learned about the formula, okay, which we have the point P to the equation of the plane. So we have actually learned about the formula there. So the easiest is to just apply the formula. Okay. Another way that we could look at it is that, okay, you can see this is like a plane pi, and let's say we have got the line L, which is like this here. So from the previous part of the questions, right, what are they actually looking for? Okay, let's see. L has a point P, okay, and then they meet at this point here, 2, -311. Okay, and this line L here has a point P here, and the point P, okay, let's say we just write down what is the coordinate of the point P. The point P here is 2, -35. Okay, it has got the 2, -35 here. And then also there are a few things that we have also found already. For example, like part C, the acute angle between the L and the pi. So it's 39.8 or the theta. So you can see that we can actually use this idea here. So the perpendicular distance from the P to the pi, right, is actually we are looking at this part here. This is a distance. Okay, so the distance here is, we're actually looking at the hypotenuse, okay, and then we are multiplying with the sine theta. So the hypotenuse is having the distance, which is like 11 minus 5 squared, which is 6, and then multiplied by the sine theta. Okay, so this distance here is a 6, okay, and then we are using the sine theta. So it's a 6 sine theta here is this value here, okay, 3 over sub 32. So we get a 18 sub 22. So it will give us the same answer as well. Okay, so you can see other than using the formula, because in this question here, it is being like designed so nicely that everything will lead us to the last result that we want to find from there. Okay, so not just always like apply the formula, that it helps us actually quite a bit, okay, for the previous part of the questions here. Okay, so different approach that you could look for when you try to find this part D here. Okay, right. So this, I feel that this vector question is actually quite interesting. Okay, anyway, so let's look at the next part. So we have got this curve C, okay, having this polar equation. The theta is only from 0 to half pi. Find the polar coordinates of the point on C that is furthest from the pole. So the furthest from the pole means we are looking at the distance, okay, the furthest distance from the pole. And the distance from the pole is denoted by the r itself. Okay, so for this one is nothing much, is to find the d theta. Okay, and as we are finding the d theta here, right, we could actually look at it as something like this. Okay, we can differentiate them by using the product rule, and we can get this already. So after that, okay, is to make the d theta equals to 0. So we know that we have like cos square, sine square, and also a sine, which we could be solve. Okay, we could solve this by using the sine. Okay, everything in terms of the sine there, and it's actually quite nice at the end. So it will lead us to a quadratic. And for the quadratic that we have here, one part of it we have no solution because the theta is in the first quadrant. Okay, the theta is in the first quadrant here. So the only solution that is giving us, like from here, is the theta is a pi over 6. So because they want us to find the polar coordinates, yeah, so we need to find the r as well. So with the theta, substitute into the r there and find out what are the values from there, then we can get the value of the r. Okay, so this is the point where we have got the curve is furthest from the origin. Okay, it's just the dr theta. Okay, so it's to sketch C. So usually, like I said, all the time, if the sketch comes after some question, so we are expected to use the feature to help us. Okay, we are expected to use the feature to help us. So of course, the feature that we actually know from the first part of the question is that when the theta is a pi over 6, it should be the furthest from the pole. So okay, we can actually mark the line which is theta is equal to pi over 6 here. Okay, and now we can actually start sketching. But before we start sketching, it is also helpful to know what are the values of the r. Okay, when we have got the starting and the ending value of the theta there. Okay, so we get the theta is 0, so the r is a 2. And then when the theta is a pi over 2, the r will actually goes to a 0. So you know that it will actually go to the pole at the end here. So we just have to join the r there. Okay, from the 2 to the 0 there. And one feature that we are supposed to show is that at this point here, it is actually furthest from the pole. Okay, it is actually furthest from the pole, or in other words, it's actually a maximum r. Okay, you need to show this feature here. So you can mark, like I said, the theta equals to pi over 6 here, and then you just show that that is actually the furthest from the pole. This is how the shape of the graph would look like. Okay. So the next one is find the area of the region bounded by the curve. So basically, it's everything. Okay. So for this is a bit of the work. Okay. So we can see the amount of the work that is involved here. We need to have the r integrate r squared d theta. So r squared itself is not straightforward here already because we have got the 1 plus sign, we have to square that. And after that, we could expand it. Okay, so when we expand it, we got this kind of the terms here. So we have got 2 cos square, then we've got like a cos square sine square here. Okay, for the first one, we are going to use the double angle formula. So cos 2 theta is a 2 cos square theta minus 1. So something that we could factorize, something that we could integrate, sorry. Something that we could integrate already. Okay, and then the next one, this one, 4 cos square sine, we will leave it there first, and we will see what happens. These, okay, we are changing it to the double angle formula, okay? So this double angle formula is coming from like sine 2 theta is a 2 sine theta cos theta. So when we change it by using this, right, it gives us a 1 over 4 sine square 2 theta. And for this sine square, right, we are still not able to integrate it straight away. So we have to make use of another round of the identity changing. So now we use the double angle formula for the cos. So cos 4 theta is 1 minus 2 sine square 2 theta. So this is what we get. So now finally we can integrate. Okay, so tidy up the stuff here. So we have got the first two terms. Okay, the first term and the last term, sorry, that we could integrate from there already. So integrate the cos 2 theta gives us a half sine 2 theta. And the rest of it is a similar. Okay, so the next thing here, yes. So we're going to integrate like 4 cos square sine. Okay, we have got a power of cos with an extra sign out there. So we could think of, okay, what have we differentiated such that we get a cos square with an extra sign there? So, okay, we might have differentiated something which is in terms of the cos cube. So when we differentiate the cos cube, we will get a cos square sign thingy like that. Okay, and after that, okay, we just have to sort of like adjust the values here a little bit, the coefficients here a little bit. So we could try to work backward and see whether we differentiate this thing here and we are actually able to get this 4 cos square sine theta there. Okay, or you could use a substitution. You can sub the u is equal to cos theta here. You could do the substitution as well. Okay, but no matter what is a method that we use to integrate from there, so after that is to evaluate everything. So just sum in the values like pi over 2 and 0. And at last, it is actually not too bad because lots of things will give us a 0. So the only remaining terms that we have here is only this constant here. So 5 pi over 8 plus a 4 over 3. Okay. So not a lot of things actually, but it's all about like our skills in integrating only. Okay. So let's look at the next question. Okay, let's look at the question 7. So this is the equation where we have got like 4x plus 5 over 4 minus 4x squared. For this one, we know that we could sort of change it into the partial fraction, but sometimes we might not need it. Sometimes we might need it. Okay, it depends. But the important thing that we want to look at it here is that about the asymptotes. So if we change that into the partial fractions, then we are getting something like 2 minus 2x, some constant, plus b over 2 plus 2x. So from here, of course, the vertical asymptotes are what we know. Okay, we can identify from that straight away. And for the horizontal asymptote, we have to be careful. If we don't see a constant, then usually it will be the y is equal to 0 for the asymptote here. Okay. So if we look at the next one, right? Okay. So next part. So it's to find the coordinates of any stationary points on C. So you can see here, if we didn't do the partial fractions, right, it might be a little bit difficult for us to like carry out the differentiation here. Okay, compared to if we have done the partial fraction. So if we didn't do that, it's okay. We can still use the quotient rule to do that. Okay, it's just slightly more work for that. Okay, for the quotient rule there, but it's okay. So we could equate that to the 0 for the dy dx after we have used the quotient rule. So this is a nice quadratic that we could factorize, nicely. So we will have like, oh, this is the values of the x that we have. Okay. After that, what we will see is that, now they want the coordinates, really. So we have to sub in the x into the y there to actually get the coordinates. Right? So the next one, right, is to sketch, the C stating the coordinates with the axis. So very easy to find the x and the y coordinate. So we just have to let the x and y to be 0 there. From what we have actually know earlier, so we have got like the turning point that we can plot earlier, and also the intercepts. Okay, so with the turning points and also all the intercepts there, right? Then we could already join the graph, and then this is what we have. Okay, so take note that y equals to 0 is also an asymptote there. So for the first part of the graph here, because it has got like a turning point here, it will actually cross over. Okay, it will actually cross the horizontal asymptote here. Okay, so that's the graph. Okay. Part D. Sketch the curve with this equation, and find in exact form the set of the values of x for which we have got this inequality here. So what happened here is that, we want to sketch this, right? This is actually we reflect the graph. Okay, so reflecting the graph, not an issue. It's quite easy to reflect that. Okay, so we have to solve this one. So this is actually when we rearrange it, right? It is actually this one here. Okay, it is actually to solve the modulus is greater than 5/4. So, it's a greater than, and if you actually notice, where is the 5/4? The 5/4 is actually here, our y-intercept there. Okay, so they are actually different points that we have got the intersections there. Okay, so we can see the first and the last value here is actually obtained by considering the reflected graph. So these are actually reflected graph. So these two values are obtained by solving 4x plus 5 over 4 minus 4x squared equals to negative 5/4 because it is reflected. So when we want to solve this value here, we need to use a negative of it. Whereas the middle two values here is obtained when we solve the equation is equals to 5/4. So it is, so again, for this kind of the question, is always like, we find the intersection first, then we see the graph. Okay, what are the ranges that the x that it actually gives us there? So we want to have a greater than 5/4. Okay, so with that, we solve each of the equation there, the plus and the minus of the 5/4, that it actually gives us like different values here. So we have got 0 and negative 4/5. Okay, so this is 0. This is negative 4/5. Okay, and the two values, at the ends is this 2 plus minus 3/6/5. So this value here is 2 minus 3/6/5. This is a 2 plus the 3/6/5. So we just need to look at what are the range of the values of the x such that this graph is greater than 5/4. So this graph is greater than 5/4 in between here and in between here. Okay, it's greater than 5/4. So we just need to state what are the values there. Okay, but for this one, what we have to be careful is that even though you can see for here the values, if we didn't look at the asymptote, is something like this. If you don't consider the asymptotes, again, I'm saying, okay, and then we have got another one is from 0 to the 2 plus 3/6/5. If we do not really care about the asymptotes there, but this is a dangerous part. We have to look at the asymptotes, okay? So the the in the mark scheme, right, they might actually allows us to include the asymptotes, which is x equals to -1 and the positive 1 here, but better we don't include that. So we still have to split that, okay, into a few parts here. So for the first one here, we need to separate that by using a -1. Okay, so it will become like something like this, -1 x -4/5. For the second one here, we need to separate the 1 out. Okay, so finally, the answer that we are getting will have like 4 parts here because they're trying to separate the 1, the -1, and also the 1 out. Okay, so this would be the inequality that is that we should write. So we have to avoid the -1 and the 1, which is the particular asymptotes there. Okay,